Hey everyone, so today we're going to talk about solving absolute value inequalities. This is what we talked about in class, but this is a helpful video for those of you that maybe need some reteaching or need to go over the lesson again. So when we're solving absolute value inequalities, there are two keywords that we're going to use. The first is conjunction. And when we say conjunction, we mean and. And the other term that we're going to use is disjunction. And with disjunction, we are going to use or. So when we're talking about conjunctions or disjunctions, if I have a number line, and I say this is 0, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, say I want 4 and 7. Then this would be, and I'm actually going to do this in a different color, a conjunction would be between those 2 points. And so we would say that x is greater than 4 and x is less than 7. X is greater than 4 and x is less than 7. So, and the inequality that I would write for that is 4 less than x less than 7. With a disjunction, instead of saying and, we are now saying or, so we could have we have 2 separate intervals. So if I say, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, here is 4, 5, 6, 7. A disjunction, if I make my line a little bigger here, a disjunction is going to say that x is less than 4 or, sorry, I almost put and, or x is greater than 7. So this is how we're going to distinguish between a disjunction and a conjunction. Okay, so those are 2 separate things. So let's go through an example of how we would solve an equation, how we would solve this an inequality like this. So if I want the absolute value of positive x plus 2 is less than 8. So the first thing that I want to do is I want to find my solutions, or I want to find my x-intercepts. And to do that, we're going to solve this just like we would solve an absolute value equation. X plus 2 equals 8, x plus 2 equals negative 8. So x is equal to 6 and x is equal to negative 10. So on a number line, the next thing I'm going to do, so here are my 2 solutions, x equals 6 and x equals negative 10. So now I need my number line. And let's say that 0 is here, and here is negative 10, and here is positive 6. And that's the bell because I'm taping this at school. Okay, So the first thing that I need to do is the next thing I need to do, the next thing I need to do is because this is a less than sign, what I'm going to do is say that this is a conjunction because it is less than, and I am going to place an open circle at both of these points. And because it is a conjunction, my solution set is going to be in between -10 and 6. So my solution is a conjunction where x is greater than 10 and it's less than 6. Let's try another example together. So we'll make a little more complicated example. 2x plus 4 plus 3 is greater than or equal to 10. So I'm going to treat this as an equation. And I'm going to subtract 3 from both sides. To get 2x plus 4 equals 7. So 2x plus 4 equals positive 7. 2x plus 4 equals negative 7. I'm going to work through some algebra there. 2x is equal to 3. So x is equal to 3 halves. 2x is equal to negative 11. So x is equal to negative 11 halves. So those are the two solutions. Now I'm going to go through my number line. And because this is greater than, this is representing a disjunction. So on my number line, here is 0. Let's say 3 halves is here, and negative 11 halves is here. So I'm going to place closed circles at those 2 points. They are closed circles because we are greater than or equal to. And then the line that part of the line that I'm going to shade is that greater than and that less than. So this is a disjunction. And my solution set is x is less than or equal to negative 11 halves, or x is greater than or equal to 3 halves. Okay. So those are 2 examples with a conjunction and a disjunction. Let me kind of also reiterate that a disjunction will always be a less than or equal to sign, and a conjunction, wow, sorry, I totally mispronounced that. A conjunction will be less than or equal to. A disjunction will always be greater than or equal to. Okay? All right, there you go.